All right, guys, so some of you are struggling with this one, and we didn't have time in lesson to finish off the full worked example. I don't want to leave you in a state of confusion, so I'm going to run through this example and share it with you on Classroom. So this is the diagram of what's going on. First off, we're going to label up a whole load of things on the diagram. We've got Cynthia's weight. I'm going to call that FC. We have the mass of the beam acting with a weight down here, so we'll call that F beam. And we've got Stan's weight acting down through here, and so we'll call that FS for force of Stan. In fact, I'll use Stan so I don't get confused with support force. Okay, we have an upwards acting force from A, F support A, and an upwards acting support force from B, so that's F support B. I haven't done these arrows to scale, I hope you'll forgive me, just in terms of trying to make this video quite quickly for you. Okay, so the things that we know are that the sum of the forces upwards equals the sum of the forces downwards. And we know that the sum of the torques clockwise equals the sum of the torques anti-clockwise. We need to identify a pivot, and so I think in class we decided that that was going to be our pivot. And because any force acting through the pivot is doing so a distance of 0 meters away, we can ignore that force because it's not going to contribute to the torques involved. And then we're going to use torques in order to figure out the missing quantities. So what are we trying to find? Well, if this is our pivot, then we're trying to find support force B. So FSB is our unknown. Distances are really important here. And so we've got from the pivot, all of the distances, remember, are measured from the pivot. We've got 1.0 meters to Cynthia, and we've got the beam there. Now the plank is 5 meters long and there's 50 centimeters hanging off the end here, which means that from the pivot, we've got a distance of 2.0 meters there. Okay, for Stan, I'll come and do his distance up here. We're told that he stands 1 meter from the other end, which means it's 4 meters from the edge of the plank to Stan, but because there's half a meter there before the pivot, it means that from pivot to Stan is 3.5 meters. And finally, we go from pivot to FSB, support force B, and we know that that's going to be with half a meter off each side, that's going to be 4.0 meters. I'll just bring that down a bit so you can hopefully see that. Okay, now the sum of the torques tells us that the torque provided by Cynthia in the clockwise direction, plus the torque provided by the beam in the clockwise direction, plus the torque provided by Stan in the clockwise direction, are all clockwise. And so when we add those together, we are going to get an equivalent torque to the anti-clockwise torque provided from support force B. So let's go ahead and start working some of those out. Torque of Cynthia is equal to her force times distance, which is, now she's 54 kilograms, or 54.0 kilograms, which we times by 9.8 to turn it into force. And then we multiply by distance from the pivot, which is 1 meter. And that comes out to 529.2 Newton meters. We've then got the torque of the beam, which is equal to the force of the beam, the weight force, times its distance. And so that is 20 kilograms times 9.8 times, it's 2 meters away from the pivot. And that comes out as 392 Newton meters. And then we've got the torque from Stan, which is equal to the weight force of Stan times his distance from the pivot. And he is 76 kilograms, which we're going to multiply by 9.8 to get weight force, and then times a distance of 3.5, that's that one up there. And that gives us 2,606.8 Newton meters. Okay, So the torque provided by ladder B, so the torque from ladder B is equal to the torque of Cynthia plus the torque of the beam plus the torque of Stan. And so we know that when we add these together, we get the same torque as is provided in the anti-clockwise direction from the support force at ladder B. And that comes out to be 3,528 Newton meters just from adding these three together. Okay, so then we want to know the force of ladder B, which is equal to, remembering our equation is torque equals force times distance. So if I write that over on the side there, torque equals force times distance, then force is equal to torque divided by distance. If you're not sure about how to rearrange that, make sure you see me. And so that's our torque of ladder B divided by our distance from A all the way to B. So I'll put A to B there. So that is 3,528 Newton meters divided by 4 meters, which comes out to 882 newtons. And that is in the upwards direction from support force B. Okay, now we could do that in reverse by identifying this as our pivot and working it out for support force A, but the shortcut lets us, if we know that the sum of the forces up equals sum of the forces down, then we can take the total downwards force and we can subtract the upwards force from B, and whatever's left is our support force A. So I'll just run through that. That is 54 times 9.8 plus 20 times 9.8 plus 76 times 9.8. That gives us a total downwards force. Where can I write this where you guys will see it? So the force downwards, the sum of the force downwards is equal to 1,470 newtons. And we know that the upwards force from B is 882. So support force A must be 1,000, support force A must be 1,470 minus 882, which is a shorter way of working it out. And that gives us our 588 newtons. As I say, you could try doing that. You could just make B your pivot and then work it out for A, and you'll get exactly the same answer. All right, I hope that was helpful. Have a great day, and ask if there's anything you're not sure of.